Hello, in this video we're going to look at the substitution and scale effect of a wage increase using a detailed mathematical example. Here we have a firm that faces the following inverse market demand, has the following Cobb-Douglas production function, and has input prices where the wage is $4 per unit and price of capital R is $16 per unit. We want to find the substitution effect and scale effect. Sometimes the scale effect is called the output effect on labor and capital from a wage increase from $4 to $9. The first thing we're going to do is get the marginal product of labor, taking the partial derivative of the production function with respect to L labor. We get the following result. This 1/2 comes down in front, and then we subtract 1 from this exponent on the L term, leaving us with this. We get the marginal product of capital, very similar looking partial derivative. The 1/2 on the K comes down in front. We subtract 1 from the exponent on K, and we're left with the following. Forming our cost minimizing input condition, which states that the marginal rate of technical substitution equals the ratio of the inputs, the price of labor over the price of capital. The marginal rate of technical substitution is just a marginal product of labor divided by the marginal product of capital. So I'm making my substitution here from the first slide. So in the numerator, that is the marginal product of labor. In the denominator, we have the marginal product of capital. Now we're going to simplify. So the 0.5s cancel. L to the minus 1/2 over L to the 1/2 just leaves us with L in the denominator. And then the K's here will just simplify to K in the numerator. Solving this for K, we have the following, and we could also solve it for L, which will be convenient later. Our next step is to take this first expression where the capital equals the wage divided by the price of capital times L and plug it into our production function. Here's our production function. Where we have K, we're going to replace it with this term up here. And now we're going to simplify. And simplifying some more. L to the 1/2 times L to the 1/2 is just L. Simplifying a little bit more, we have what is called the conditional input demand for labor. And now we had that expression earlier, L equals R divided by W times K. Let's now plug that into the production function. Where we have L, we're going to replace it with this term up here. And now we're going to solve this for K. Simplifying the right-hand side, multiplying through by this reciprocal, and we get the conditional input demand for capital. Here's our two conditional input demands that we found. Let's form the cost function. So we have the firm's total cost. Where we have L, we're going to replace it with this term up here. Where we have K down here, we're going to replace it with this term over here. So making those substitutions of the input demands into our cost function and simplifying. We get this nice result right here. W divided by W to the 1/2 is just W to the 1/2. R divided by R to the 1/2 is just R to the 1/2. So just adding up these two terms, and we have the following. So again, our cost function. And let's get marginal cost by taking the derivative of the cost function with respect to Q. And at a wage of 4 and a price of capital of 16, we'll notice here that the marginal cost is $16 for the firm. So let's now do some profit maximization by setting marginal revenue equal to marginal cost. We first need to get marginal revenue. We have the price equation, inverse market demand for the firm. Forming the revenue equation, price times quantity, where price is 36 minus Q, and that's all times Q. Taking the derivative of that, we get marginal revenue. Now setting marginal revenue equal to the $16 that we found for marginal cost and solving for Q. Q equals 10 and Q equals 10. And in terms of the quantity of labor hired, taking our conditional input demand for labor and evaluating it at the input prices, and where Q is 10, the firm would hire 20 workers. And doing a similar thing now for capital, the firm would hire 5 units of capital. So let's calculate the substitution and scale effect on labor and capital if the wage increases now to $9. So the substitution effect, we're going to find that by holding output constant at 10 and changing the relative price to labor. Wages going up from $4 to $9. So the conditional input demands, when W is 9 now instead of 4, and again we're holding output constant at 10, the firm would hire 13.33 workers. And in terms of capital, the firm would use 7.5 units of capital. At W equals 4 and R equals 16 and Q equals 10, we found that the firm would use 20 units of labor and 5 units of capital. We just found at this new price here for labor of $9 that the firm would use 13.33 units of labor and 7.5 units of capital. So to sum up then, the substitution effect of the wage increase caused the firm to decrease labor from 20 units to 13.33 units. This 20 up here to this 13.33. Again, we're holding output constant. That's how we're getting the substitution effect, just looking at the relative change in the input prices. And the substitution effect of the wage increase caused the firm to increase its capital from 5 units to 7.5. So 5 that we found originally and the 7.5 that we found on this screen. Okay, moving on. The scale effect. So the increased wage will cause the firm's marginal cost to increase, and then this will affect the profit maximizing output level. So when the wage is 9, this higher wage, the firm's marginal cost, using our marginal cost equation and now plugging 9 in it instead of 4, the marginal cost for the firm is now $24. So setting marginal revenue equal to marginal cost, the firm does indeed produce less output the higher the marginal cost. And so now, with this higher marginal cost, producing only 6 units of output at these input prices, the firm would only use 8 units of labor and 4.5 units of capital. So the total effect of the wage increase on labor, we notice here L decreased from initially 20 to 8. We found 8 right here. So the total effect from the wage increase caused the firm to use 12 fewer units of labor. So the substitution effect of the wage increase is going to be 20 to 13.33 or 6.67 units. So that was the substitution effect. The total effect is going to equal the substitution effect plus the scale effect. So the total effect, labor fell by 12. The substitution effect caused the firm to reduce the number of workers hired by 6.67. So now we're just going to solve for the scale effect here. And that's going to be minus 5.53. So because the relative price of labor increased, the firm substituted capital for labor, causing labor to decrease by 6.67 units. That is the substitution effect. Because the cost of production increased from the higher wage, as we saw, the marginal cost increased, the firm reduced output, causing labor to fall by 5.53 units. So the 6.67 plus the 5.53 is the total reduction in labor. So we're just decomposing this total reduction in the number of workers hired into a substitution effect and a scale effect. And to look at the total effect of the wage increase on capital, similar thing here. Capital decreased from 5 to 4.5 or 0.5 units in total. The substitution effect of the wage increase on capital, capital increased from 5 to 7.5 or 2.5 units. So because labor became relatively more expensive, the firm decided to use more capital. And in terms of the total effect, we see the total effect, capital fell by 0.5. Substitution effect, capital increased by 2.5, so now we just need to solve for the scale effect, and that's going to be minus 3. So because the relative price of labor increased, the substitution effect, the firm substituted capital for labor, causing capital increase by 2.5 units. Because the marginal cost increased from the higher wage, the scale effect, the firm reduced output, causing capital to decrease by 3 units. So taken together, the plus 2.5 and the minus 3, we get the overall effect here of a reduction in capital of a half a unit. So overall, the increased wage caused the firm to use less labor and less capital. In this example, labor and capital are said to be gross complements. Inputs are gross complements when the firm uses less of both inputs as the price of one input increases. For capital, the scale effect dominates the substitution effect. All right, let me stop here.